Hello, my name is Catherine Johnson, and I'm a student in JGen 200. Today I have a topic for you called lightning, a common topic. And before we can understand really how lightning works and where it comes from, we first must understand a more common topic called the water cycle, which is evaporation and condensation. So if we think about the water cycle, think about, for example, a rain puddle. So say the rain puddle doesn't sit around for days after it rains, right? It evaporates. And this is because energy from the sun comes down into the puddle, heats up the molecules, they get energy, move around, free themselves, and evaporate. Then condensation is when the water loses that energy because the heat from the molecule moves into the cooler air, and then the molecule turns back into a liquid state. Therefore, the gravity then from the earth pulls that liquid down back onto the earth, causing it to rain again, and then the repeat of the water cycle. Now let's talk about electrical storms. Storm clouds are like giant charged capacitors or batteries in the sky. The clouds become charged because the millions of evaporated water droplets in the sky accumulate in those clouds. These droplets collide with each other and electrons are knocked off of each molecule. Some freeze while some remain unfrozen. The frozen molecules are negatively charged and the unfrozen molecules are positively charged. If you look at this figure, we have a charge separation of molecules. This is causing an electric field. The positive electrons go upward, the negative ones stay at the bottom of the cloud. As more collisions take place, this field becomes more and more intense, so intense in fact that the negative electrons on the Earth are actually repelled by the negative electrons on the bottom of the cloud, leaving only positive electrons on the Earth's surface. So now that we have this electric field, all that's left is a conductive path. We needed a conductive path because a strong electric field actually causes the air in the cloud to break down. This allows current to flow in an attempt to neutralize that charge separation. Everything in Earth always wants to go from a charged state to a neutral state. Because the charge in the clouds is so great, it really wants to neutralize. So simply stated, the air breakdown causes a path. And that path is through the air and it short circuits the ground to the earth, just like if there was a long metal rod connecting the earth to the cloud. So essentially the air is a conductor between the cloud and the earth at this point, allowing the electric current to flow. The reason lightning bolts actually aren't straight from the cloud to the earth as you might expect, they are more in a zigzag pattern. This is because the air does not ionize equally in all directions. Dust and impurities may affect how the air breaks down, and the lightning strike will always want to take the path that's easiest for it. So as you can see these little fingers coming off the lightning strike, they stop here because the air didn't ionize all the way, and over here it did, so it took this direction. Once the path to the surface of the earth is found, the lightning strike will actually follow. And it's going to be a sudden massive flow of electric current moving from the cloud to the ground. When the path completes, the current flows between the earth and the cloud, discharging the current. That's nature's way of trying to neutralize the charge separation. So now that we understand lightning, let's talk about thunder. Because there is an enormous amount of current in the lightning strike, there is also an enormous amount of heat. A fun fact is a bolt of lightning is actually hotter than the surface of the sun. Because the lightning strike is so hot and the air around the strike becomes so extremely hot it actually explodes. And the heat of the air around the lightning bolt expands so rapidly that it creates a compression wave that creates a sound wave to flow out of the lightning strike, and that's what thunder is. And the reason you might think that thunder and lightning aren't the same is because you hear thunder so much later than you hear lightning. But that's because light travels so much faster than sound. Sound travels only at 0.2 miles every second. That's 0.2 of a mile every second. Sound travels 186,000 miles per second. That's so much faster. So if you think about it, if you see a lightning strike and you count seconds until you hear the thunder, every 5 seconds is 1 mile away you are from that lightning strike or where the lightning strike was. So in conclusion, lightning is from the charge separation of the molecules in the cloud causes an electric field. That electric field wants to neutralize, and that connects with the ground, finds a path at the least resistance, and makes the electric current, which is the electric current flow, which is the lightning strike. And thunder is just the sound of the heat getting warm around the lightning strike and expanding so rapidly it explodes. So yeah, I hope you guys enjoyed it. Thanks.